Hi, welcome to myprocesspaper.com. Now let me discuss about the title of the process. Title of the process is Secure Order Bucketization. The main objective of this paper is introduce a new encryption scheme, encryption with ordered bucketization, that is called where a range query can be supported efficiently while preserving high level of security compared to the existing methods. So we may give the modified title for this title is INTCPA Secure Semantic Encryption Bucketization or efficient retrieval by using SQL operational access in encrypted database. Now let me discuss about the abstract of our process. This paper deals with ordered bucketization, that is called OB as a cryptographic object. In OB, plaintext space is divided into a predefined number of buckets. Consider the number P, then assign a number to each bucket from 1 to P. With bucketization including OB, various types of SQL queries over encrypted data are possible if the bucket number, which corresponds to the original plaintext before encryption, is attached to each encrypted data. For example, if a client program wants to retrieve the data in the range between 100,000 and 200,000, it first calculates the numbers of buckets. Suppose union is the smallest set that covers a queried range. So then this paper defines an encryption scheme with OB called EOB and suggests a new security model for EOB called INDOCPAP, which assumes the adversary has reasonable power. Bucketization is particularly more helpful for range queries if the bucket number is assigned an ordered number. For example, in the same case reported in the above paragraph, the client needs to send two bucket numbers, one that includes 100,000 and the other that includes 200,000. In this sense, OB can be a replacement of an order preserving encryption that is called OPE. This approach is very efficient compared to the case where the client receives all the encrypted data from the server and decrypts all the data items to obtain the correct query result. Therefore, this method is very useful when users cannot store the data without encryption, such as in a cloud computing environment. Now let me discuss about the complete data diagram of our process. In that process, first user enters into the process. After the user data owner enters into the process, user data owner must select that data and must partition the data into buckets. So our original data is considered as the M and it will be partitioned into the buckets as the M1 encrypted Mn buckets. After that data has been ciphered, after the cipher data set, data can be uploaded or stored into the server. After that, upload into the server. After if the requester comes into the process, means requester issues some original queries with metadata to the query translator. Then query translator sends it to query into the server. Server pertains to SQL operations and retrieve the results of requester sends query which is sent by the requester. After that, requester receives a query encrypted data from the server. After that, query translator decrypts the results by using the metadata, then forward to the requester. Requester can view that original data by using decrypt the original data by using the metadata in the data set. Now let me discuss about the demo of our process. First we have to run homepage.java. The modified title for our process is efficient retrieval by using SQL operational accessing encrypted database. Then click next. Data owner must choose a data. Click data view, then say click here just load user data into the database, then view the data from database. So here we are going to show the object data, then attributes in the data will be displayed here. After that, here we are going to bucketize the data in a plain text. So here we are bucketize the data into two buckets. bucket 1, bucket 2 based upon some constraints. Then here we are partitioned into 4 clusters: bucket 1, bucket 2, bucket 3, bucket 4, 4 number of buckets based upon some constraints. And click next button. Here we are going to encrypt the data, user data. So these are the attributes in the data set. So here we are using the UES encryption for encrypting the data. We have to encrypt each and every attributes in the data set, data of the owner. So for encrypting each and every attribute of data means we can secure the process efficiently. These are also attributes of the data set. After that, you have to select the buckets. Select the buckets. Data are partitioned. Show the bucket values in the encrypted data. So in the encrypted data, you can view the bucketized data. Then click next. Data partition in encrypted data. So request sends some issues. Some query means about the attribute. Just we give the user ID, then enter the metadata. So just click the user input, then click another button. So here user request processed query will be displayed here. Then cipher query will be processed, and then cipher text query will be processed here. Then click plain text, decrypt details, then plain text will be processed here. This is a normal process in encrypted data. So another process is we are going to process our range query in encrypted data. So just get encrypted data. Select age in encrypted data. So just decrypt the file, then retrieve the results within the reduce. The encrypted results will be displayed here. Then get upper bound values, then lower bound values, then choose any one of the attribute. Encrypted results based upon these ranges, then encrypted results will be displayed here. Then decrypted result based upon these values will be displayed here. Then based upon the bucket sizes, we are calculating the positive ratio computation. So here we have a 0.948 for positive rate computation. So number of occurrences of the query keyword, then total number of rows, relevant scores can calculate based upon the number of occurrences of the query keyword and total number of the words. So based upon this, here we are going to evaluate the process. Then FPR in percentage. This is a complete demo of our process. Thank you for watching.